it's kind of a rough depiction of a somewhat typical microgrid system. This one happens to be AC coupled, which is kind of, I would say, the most common, typically, unless there's a good reason to be DC coupled. There's just more options, I think, out available for AC coupled. I think a lot of times it's easier to design around with AC coupled these days. So yeah, going through some of the components, if you're just kind of walking through it, you have the inverters over there. There's obviously modules coming into the inverters, and then they all tie together in a recombiner panel board. There's much more that is not being shown there, but that comes in as an AC being added into everything being combined, in this case, in the main switchboard. It goes through a PV disconnect and a grid isolation contactor before it gets to the main switchboard, but it's coming into the main switchboard as a breaker. And then right next to that breaker, you have the other breaker coming in from the BES system. And like I said, with the PV2, that has its own separate disconnect there. And then this one has an isolation transformer, and that's why it's 480 delta to 480 Y. There's no change in voltage. It's strictly there for isolation. And Brian, I don't know if we want to get into kind of why an isolation transfer or why a transformer or why not. It's kind of a big topic, but
yeah, it's kind of a long topic. That short answer is that some of the energy storage systems can produce a voltage that can damage electronics, so that needs to be filtered out before it gets to the electric grid. That's why these isolation transformers are there. Yeah. There are several other reasons they could be included. When you're doing resiliency projects, some energy storage systems don't include a neutral, so we need to add a transformer to have the neutral to feed single phase loads, or have the transformer if we need to change in voltage. But in this case, it's 480 to 480, and this transformer was included for the neutral to feed single phase loads.
Yep, that makes sense. Okay, yeah. So then I guess also this system has a generator included, and again, everything's coming together in that main service panel. It wouldn't have to. Sometimes there's a separate panel board and then one breaker tying into the panel that's being backed up. This one, and we're just using this main switchboard to bring everything together. And then down on the lower right too, just to kind of talk about what that is a little bit, the controls and some of the other systems that are part of the BES need to run on 208. So there's another separate feeder there to feed those loads. So there's a 480 to 208 transformer there, and a little disconnect for those loads in the BES. So
yeah, that's often for HVAC units is one of the more common things we need to power an auxiliary transformer.
Yeah.
So yes, I think as you know, we're looking at this, there's multiple ways to go about it. In this case, we're using motorized breakers and a microgrid controller to do that isolation from the grid or connection to the grid, as the case may be. And so, you know, sometimes we'll actually see contactors. Sometimes if it's a small enough system, might be integrated. So that microgrid interconnect device might be integrated with the power electronics. And so, you know, this is just one of probably lots of ways that we can do this. Just kind of wanted to show that to folks.
Yep.
Yeah, this was a pretty large project. I believe that main was either 2,000 or 4,000 amps. So doing a motorized breaker on that made sense, where a contactor at that scale didn't.